This is Step Paper 1, 2004, Question 3, in which we are required to prove that x minus 3 is a factor of f of xy and then to factorise the whole thing, where f of xy is x cubed minus 5x squared plus 2x squared y plus xy squared minus 8xy minus 3y squared plus 6x plus 6y. And so, taking advantage of the factor theorem, we put in x equals 3, so we have f of 3y, which leads to the sum given, and you'll see that we've got 3y squared minus 3y squared, and if you work out the arithmetic, we have plus 18y minus 24y plus 6y, and the numbers come out to 0 as well. And if we look at the sum as given here, you've got 27 minus 45 plus 18 is 0, and all the y elements turn out to be 0. And so by the factor theorem, x minus 3 is a factor of f of xy. And so f of xy will have the form x minus 3 times x plus ay plus b times x plus cy plus d. But we have no term in x to the naught, y to the naught. So BD equals 0, and because nothing else is given, we can choose that D shall be 0. And so the form of the factorization will be as given, and if I choose x equals 1 and y equals 0, that will come to minus 2 times 1 plus b times 1. And then here, on the right-hand side of what 1 minus 5 plus 6 equals 2, that is what f of xy evaluates to when x equals 1 and y equals 0, and so b equals minus 2. And so with b equal to minus 2, the factorization will have this form given here, x minus 3 times x plus ay minus 2 times x plus cy. And if I compare the coefficients of y squared, I find that AC equals 1. And having found that AC equals 1, if I put x equal to 0 and y equal to 1, I've got minus 3 times a minus 2 times c equals 3, which means that AC minus 2c is minus 1. I know that b is minus 2. I found out a moment ago that AC is 1. AC minus 2c is minus 1, 1 minus 2c is minus 1, minus 2c is minus 2, and so c equals 1. And AC equals 1, so A equals 1, C equals 1, and B equals minus 2. And so using those values, I have my factorization. X minus 3 times x plus y minus 2 times x plus y. In the second part of this question, we have to factorize g of xy, which is 6y cubed minus y squared minus 21y plus 2x squared plus 12x minus 4xy plus x squared y minus 5xy squared plus 10. There is no term in x cubed, so there must be a factor of the form py minus t. And so we are going to see if we can use the factor theorem to find a factor in the form of y minus t, and after a few, we find that g of x minus 2 will equal 0, which means that y plus 2 is a factor of g of x, and so the form of our factorization is y plus 2 times ay plus bx plus c times dy plus ex plus f. And this time there is a term in x to the 0, y to the 0, and comparing the coefficients of x to the 0, y to the 0, we find that 2cf equals 10, so that cf equals 5. Because nothing else is given, I can put them either way round, so I've got c equals 1 and f equals 5. And so if I put y equals 0 and x equals 1, I get 2 lots of b plus 1 times e plus 5 is 24, so that b plus 1 times e plus 5 is 12, because 12 is what g of xy evaluates to if y equals 0 and x equals 1. If I compare the coefficients of x squared, I find that 2 equals 2be, so that b equals e is plus or minus 1. But if we look at those factors there, b plus 1 times e plus 5 equals 12, b cannot be minus 1. So it is plus 1, as is e. And so I now have g of xy equals y plus 2 times ay plus x plus 1 times dy plus x plus 5. Comparing the coefficients of y cubed, AD equals 6. Comparing the coefficients of xy squared, minus 5 equals a plus d. So a equals minus 2 and d equals minus 3, or a equals minus 3 and d equals minus 2. And if I put in x equals minus 1, y equals 1, I've got 3a times d plus 4, which is 3ad plus 12a equals minus 6. And 3AD is 18 because AD is 6. So that leads me to the conclusion that 18 plus 12A is minus 6, so that 12A is equal to minus 24. So A equals minus 2 and D equals minus 3. And so my final factorization is y plus 2 times x minus 2y plus 1 times x minus 3y plus 5.